Okay, so we're going again. Okay, so the guess, what are we going to guess now? 2375. We're going to guess 2372. The oracle says that's too high. So the new bounds are 2369 and 2371. And look, we're going to guess 2370. And the oracle is going to respond with correct. So we found it. Terrific. Good. Now, how many guesses did we make? We can just count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 guesses, followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 guesses. 23 guesses. That's the best so far, isn't it? Because the first strategy took 2,371 guesses. The second strategy took 50-something guesses. And here we took 23 guesses. Okay, good. Any question about this? This kind of idea. Okay, so now we want to formalize these things a little bit mathematically. Then we'll move on to other things. So, formalizing these things first. The definition of the oracle function. Is that we'll say let n be a natural. Let n be a natural. The definition of the oracle function is, we'll just call it f. You can plug in a natural, and it will give precisely one of these three values, -1, 0, and 1. So you plug in a natural, and its output is going to be exactly one of those three. It is defined in the following way. F of m is -1 when m, the guess, is too small. It is 0 when m, the guess, is correct, and it is 1 when m, the guess, is too big. So if you were to plot this, so for example, if n is something small, so I can actually do it, 7, say, then the plot of this well, there's the value 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll plot the actual function in red. So for 0, what's the value? -1, so we'd have a point there. This would be -1, so 1, 2, 3, 4, 5, 6, 7. So all of these would be -1. 1, 2, 3, 4, 5, 6, 7. Finally here we would get what? 0. And then we would get all 1s from here. And these just keep going. Interesting. So with 2370, it would be just like this, except sort of dragged out to the right. 2. So in the informal illustration of what we were doing on the previous page, I'd like for you to see that there's kind of two phases to the game well, two phases to the strategy that we illustrated here. One of them is that you do not yet know bounds on the answer. Right? So when we first guessed, say, 32, the only thing that we knew for sure is that it couldn't possibly be, well, it had to be at least 17. That's the only thing we knew, because we'd already established that it was more than 16. But we didn't have, so we had a lower bound but not an upper bound. So this phase of the game, we've not bounded the answer. Then in this phase of the game, the answer is now bounded, and now we're just trying to come down onto the answer. Okay, so I'll refer to this as the up phase, and this one the down phase. So the up function is, well, it has, it will do the following. It, we'll call it, well, how about up? Up is a function from, I'll refer to this as the set of all f such that f is an oracle. And it produces two naturals. So the up function takes an argument, and its argument is a function. That's kind of interesting. A function itself can be an argument. Have you ever seen that in math before? A function whose input is a function. Derivative, right? That's an example. For those of you who've taken calculus, which is probably all of you, but not necessarily all of you. For example, the function f of x is x squared. That's a function. And then what's the derivative of x squared? 2x, which is, of course, another function. So what I want you to see is that the derivative is interesting because it's a function whose input is a function and whose output is a function. What I'm saying here is that we're talking about here, the up function is a function whose input is a function and whose output is a pair of naturals, the lower and upper bounds. So this one's going to end up being the lower bound. And this one's going to be the upper bound. So now what we want to do is we want to define a function that will actually do it. Okay. Well, this is going to be tricky. How can we define a function that will actually do it? It'll do the work, yeah?
If f of n is negative 1, then up of f of n, the lower bound is going to be n plus 1.
Okay, okay.
Up is just trying to create guesses.
Well, what it is that we want a function, up, where you plug in the oracle, miracle occurs, and out comes the lower bound and upper bound, right? Whatever kind of miracle needs to occur in there, you plug in the oracle and out comes the lower and upper bounds. Let's think about it. So here's a problem. Because the up function only has one argument, we don't know what the guess is yet. Right, so let's make a convention. What's always going to be our first guess? Let's make our first guess 1. Now let's kind of be a little careful. You need to think it through a little bit. If you guess 1, there's well, 3 possible outcomes. It could be the case that 1 is too big. Okay, then what's the lower bound? 0. And what's the upper bound? 0, right? Right? Okay. Besides, when you guess 1, what else could happen? You get it right. Ah, terrific. Then what's the lower bound? 1. What's the upper bound? 1. Okay, great. What's the other possibility? That is too small. All right. So in that case, there would be more work to do. But can you see that when you guess 1, 2 of the 3 possibilities mean that there's no more work? Okay. How about you could conceivably guess it might come to pass that you guess 4096, right? That even happened on the previous page. That happened on the previous page. If you guess 4096, there's 3 possibilities. One possibility is that that's too small. Then what would you have to do? You'd have to keep going. There'd be more work to do. What's another possibility? Too much. Okay. So if you've just guessed 4096 and the oracle says that, oh, that's too much, then what's the answer? The upper bound is 4095. No. Because if you've guessed if you just guessed 4096, then that implies that previously you guessed what? 2048, and the oracle responded that was too low. As a result, if you guess 4096 and the oracle responds that's too high, then the upper bound is 4095 and the lower bound is 2049. Okay. Suppose you guessed 4096 and the oracle says, you got it. Then what's the lower bound? 4096. And what's the upper bound? 4096. Okay, let's see if we can write this all down. So just like in some of those other cases where we had 2 functions, usually we called it like up and up 0. We're going to need an up 0. Why are we going to need an up 0? There's something that is just not manageable, and it has to do with the fact that our up function just has 1 argument. It's not that there's 2 outputs. It's that if you just have 1 input, this function has to recurse to itself, right? Somehow we're going to have to define a recursive function that does this. If there's just 1 input, and that's the oracle, then you need 1 more input to keep track of what? Your guess, right? You're going to need another one because there's 2 pieces of things you need to keep track of. You need to keep track of the oracle, and you also need to keep track of your current guess. Okay, so we'll define up 0. It is going to be a function from the set of all f such that f is an oracle. Oracle. And what will its second argument be? It'll be the guess. So what kind of thing is the guess? A natural, right? And it's going to produce a pair. Well, there's a multitude of ways you could do it, but I'm just going to have it produce both. Good. So we're going to define up of f to be up 0 of f and what? The first guess, right? And we said that what's going to be what are we going to take as our first guess? 1. Okay. So the first guess will be 1. Now we need to find up 0. Up 0 of f and m. So there's lots of possibilities that we need to work through. So 1 is special. 1 we're gonna have to treat specially. So suppose that f of m is -1. No, let's say f of m is too big. So that's saying that your guess is too big. Your guess is too big, and let's suppose that your guess is 1. You guessed 1, and that's too big. Then I claim we know the answer right now. What's the answer? 0, 0, right? Because, well, the answer has to be a natural, and if you guess 1 and that's too big, then there's only one other natural. Okay. What else do we need to handle? What's another case? Okay. So if f of m is 0, well, I claim that in this case, without regard to what m is, we know the answer. What's the answer? The lower bound is?
1.
No. What if you guess 4096 and the oracle says, you got it? Right, then what's the lower bound? 4096, and what's the upper bound? Okay, so if you guess m and the oracle says, you got it, then what's the lower bound? M. And the upper bound? M. Okay. What else? What other kinds of possible things could occur? Okay. So I think I take that to mean you're saying that what if f of m is -1? So that could occur. In the game, conceptually, that means what? You guess too low. Okay, so that means that we need to continue. We need to continue. So, which is to say we're going to need to recurse. Recurse to what? Up 0, right? So up 0. What should be the first argument? F, right? Why F?
Because the lower bound is fine.
What is F? What kind of thing is F? It's the oracle, right? It's the oracle. If you, you know, the way the game goes, like if you were playing this, I hope you can imagine playing this game on the, you know, on a road trip or something, you know. And so you're playing against someone else and they said, okay, I've thought of one, and then you start guessing. If they say that you've guessed too low, do you go on and start asking someone else? I'll just ask some other guy. No, F is unchanged because that's the person you're playing against. Okay, then what is the second argument? 2m. Okay. Have we covered all possibilities? No, right? Well, if I'm covering something up now. If that were the case, we would have covered all possibilities, right? But it's not, right? So we have f of m is 1, and m is 1. So what's the other possibility? F of m is 1, And remember that the convention is that when you write a math function and the clauses are matched top to bottom. So then writing this means that f of m is 1 and furthermore what? M is not 1. So then in that case we know the answer. What's the answer? Well, so what I mean to say is that in this case we know the upper and lower bounds. What's the upper bound? M minus 1. It's got to be m minus 1 because this would be like saying, well, Oracle, what do you think about 4096? And they say, too big. Okay. Then I guess the maximum possible answer is 4095. But you also know the minimum possible answer. What's the minimum possible answer? One more than the previous guess. So m over 2, but that's not quite right. Because if you say...
Is it f plus 1?
It won't be f. F is a person, right? You can't like add 1 to a person.
That's where it's stored, right?
No. F is a person. You know, you can't add 1 to a person. I'm not sure what that would even mean. Ah, that, right? Because, notice, for example, on the previous page, we guessed a sequence of numbers, and we came to here and said, the oracle said, 4096 is too high. Okay, so that means that the upper bound is 4095, and the lower bound is 1 more than the previous guess. But because we're guessing powers of 2, that means that we can take our guess, divide by 2, and then do what? Add 1. So in the case of, if m is 4096, that would be 4095. Half of 4096 is 2048. Add 1 is 2049. Good. Okay, so this function will establish bounds on the answer. Any question about the up function? Okay. So, what do you want to call the other one? How about down? Okay, we'll call it down. So now, the down phase, how many inputs does it have? Well, let's look at it. So this is sort of the up phase. How many items were we keeping track of? Well, 2 things really, because we've got this one item, but we're also, we have to keep track of the oracle. So it's the oracle, the other player, and then whatever our current guess is in the up phase. In the down phase, how many things are we keeping track of? 3, because we're keeping track of the oracle and the lower and upper bounds. Right. So in fact, for the down phase, we're going to need 3 inputs. Okay, so down. Will be a function from the set of all oracles and then it has 2 more arguments, the lower bound and the upper bound. And then what kind of thing does it produce? A natural, right? The answer, whatever it is. So this one is the lower bound, this one is the upper bound, and the output, of course, is the answer. Okay. Well, let's write down the definition. So down of f, and for lack of any better things, I'll write just a and b. So that is to say that the least possible answer is A and the greatest possible answer is B. So at any rate, what's going to be our guess? A plus B over 2. Now let's think carefully for a second. If you take two naturals, A and B, and you add them up and you divide by 2, is the answer a natural? Not always, right? Can you give me an example? Okay, good. How about 10 plus 11 over 2? That's not a natural. Will we need to round it, for example, with floor or something? We could use floor. That would sort of make sure that it always happened. But on the previous page, when we were actually doing it, have a look at the lower and upper bounds. They're always odd. The sum of, and furthermore, the sum of two odd numbers is even, and as a result, well, it's divisible by 2. Okay. So we're going to ask the oracle about what? About A plus B over 2. Well, the oracle could respond that that's not big enough. It's too small. Then what do we need to do? That means that there's more work to do, right? So we'll need to do down. We'll need to recurse. What's the first argument? F. Because when you're playing this game, if with someone and they say your answer is too small, you don't say, okay, I'm gonna get someone else. Right? It's the same person. So you guessed A plus B over 2. That's too small. So something is going to change, either the lower bound or the upper bound. What's changing? The lower bound is changing because you just asked about the midpoint and they said that wasn't big enough. So what's the new lower bound? Very good. A plus B over 2 and 1 more. And what's the new upper bound? B, which is to say the same as the previous upper bound. Okay. If you ask about A plus B over 2, and the oracle responds with 0, then what? Then the answer is A plus B over 2. Okay. What's another possibility? Right. If you ask the oracle about A plus B over 2, and the oracle responds with 1, then conceptually that means what? Yeah, they're saying, oh, that's too big. So that means that there's more work to do. So we'll need to recurse. What will be the first argument? F. So we guessed the midpoint and they said, oh, that's too big. So either the lower bound or the upper bound is changing. Which one's changing? The upper bound, because you just guessed something and they said that's too much. As a result, what's the lower bound? A. And what's the upper bound? A plus B over 2, and then subtract 1. Now, this is almost the correct answer. Okay, now what I mean to say is that this function, as it's written, will tell you the correct answer. But there's two objects to the game. What are the two objects of the game? To get the correct answer and the least number of guesses. So I'm leaving something as a mystery. There's a mysterious item that I'm omitting from this definition. As written, it will give you the correct answer, but it will not do it in the fewest possible guesses. It'll be off by 1, only in some cases. Okay, any questions? Okay, very good. Have a nice Thursday.